welcome to this Morpheus Tech Brief on Azure ARM templates. My name is Martez Reed, Director of Technical Marketing. We're going to go over the ARM template integration within the Morpheus platform to see how we can provision Azure resources utilizing ARM templates in the Morpheus platform. Before we delve into the integration, let's go over the Morpheus platform itself. The Morpheus platform is composed of three core feature areas: workload lifecycle management, automation and orchestration, costing and analytics. The platform provides integrations across the board in IT organizations. One of the terms we typically utilize when describing the Morpheus platform is self-leveling cement. And what we mean by that is being able to fill in the various gaps in IT organizations, private cloud, as well as public cloud, as well as hybrid cloud. When we talk about workload lifecycle management, we're referring to being able to leverage the platform to facilitate the automated end-to-end provisioning of workloads, whether they be in private clouds or in public clouds. This really simplifies the process that most have experienced, where it may take days or weeks to actually, from request to actual provisioning of a virtual machine workload. With Morpheus, we've able to simplify that process by facilitating and integrating with automation components like Ansible, Chef, Puppet, being able to talk to APIs such as VMware vSphere, being able to integrate with IPAM, DNS, CMDB, as well as backup DR. These various components that go into the provisioning of virtual machine workloads. And this enables the platform to facilitate that process that would normally take various different handoffs in oftentimes a number of minutes as opposed to hours or weeks. And this really enables the organization to move faster from request to actual provisioning. It also really unlocks self-service automation when we start talking about provisioning. In addition to the provisioning process of the workload lifecycle management, the Morpheus platform also enables day two operations, such as monitoring, logging, as well as being able to execute what we typically term as day two operational tasks via a Python script, a shell script, a bash script, an Ansible playbook to be able to perform operations like cleaning up logs or upgrading application versions. And then finally, when we talk about workload lifecycle management, the actual decommissioning of a workload. So being able to, once again, tie it and integrate to the various components in large IT environments, such as IPAM, DNS, CMDB, backup, and then being able to facilitate the proper decommissioning of those workloads. We also talk about automation and orchestration, being able to, as I mentioned, leverage that for workload lifecycle management, but also as a standalone capability of the platform to be able to execute PowerShell scripts, Bash scripts, Python scripts, Ansible playbooks in an ad hoc fashion, a scheduled fashion, as well as a self-service fashion in which, utilizing our operational workflows, automation workflows can be presented to a business user or a less technical user for easy consumption. And then finally, costing and analytics. The platform integrates with 20 plus clouds, both on-prem as well as public clouds, to get visibility into cost, as well as being able to utilize analytics for things like right-sizing guidance. Let me look at platform security of the platform. Single sign-on to enable centralized authentication via the platform, granular role-based access control, multi-tenancy is a big feature that is utilized by MSPs, audit logging. And then we start to talk about platform interfaces, ways that you can interact with the Morpheus platform. We have an ITSM integration, specifically leveraging a ServiceNow application, where the catalog items in the Morpheus platform can be easily presented up into ServiceNow to utilize ServiceNow as the request portal for your organization, but utilize Morpheus for the actual provisioning and automation of workloads. API, CLI, we also have a Terraform provider, a native or a Power UI, as we typically refer to it as well as a service catalog for simplified consumption. Now that we have an understanding of what the Morpheus platform is, now let's delve into the integration between Morpheus and ARM templates. ARM templates, or Azure Resource Manager templates, is an infrastructure as tool component for declaratively creating and managing Azure cloud resources. The Morpheus ARM integration enables the platform to utilize ARM code to deploy and update Azure resources. capabilities that this really unlocks is being able to, as I mentioned, the self-service capability of the platform to be able to utilize ARM templates as a way to provide a simplified self-service method for provisioning Azure resources. And then also the composable units that the platform supports via what we term as spec templates enables the composition of complex deployments utilizing various different units of ARM template code. All right, so we're not going to spend a whole lot of time. This is more a show than a tell. So we'll dive right into actually getting the integration going. So here we've got a number of the basic steps. And in this case, the Morpheus platform can integrate with source control to be able to integrate with a GitHub and Azure DevOps to be able to pull the ARM template code directly from source control to align with common DevOps practices. So in this case, walking through the example steps, it'd be adding the SSH key pair for the Git service account, or specifically the private key, in order for the Morpheus platform to interface with source control and actually be able to have permissions to pull down the code. Then it would be adding the Git integration in the Morpheus platform to basically provide details about the Git repository in order for Morpheus to be able to pull it down. So this is where we would tie the Git integration and the credentials together. And then finally, we would start to go through the creation of ARM spec templates, and then finally creating an instance type and layout. And so now let's jump into the platform itself and take a look at what that would look like. So I'll come to standard view. And so as I mentioned, from an integration standpoint, so I'll walk through the steps. What I'll actually be utilizing is a local instantiation of the ARM template code, but we'll walk through what that would look like. So if we go to infrastructure, keys and certs. So this would be where we would add our private key for our Git integration to source control to pull the ARM template code from. In this case, as I mentioned, utilizing local code, that would be where we would add it. Then we come into administration, integrations, and new integration, and we could specify a Git repository. The Git repository would then have our information of our repository, and we would specify the information for the repository, and then we'd be able to select the key pair to pull that code. But as I mentioned, in this case, we're utilizing local code. So I come to provisioning library, because what we're going to do is we're going to look at spec template for our ARM template. So spec template, and I've already created a generic spec template. So in this case, what I'm actually creating is a Azure container instance as part of the deployment. And so for those that have worked or familiar with ARM, a number of basic components. So specifically, we have parameters, and we've specified a number of parameters for our ACI deployment. We map that to our resources, so various aspects where we see parameters. And so we've got what is known as the spec template. So we specified ARM template as the type. And so now what we need to do is the spec template then rolls up to a layout. So in this case, we've got our Azure ARM demo app. And so we have the layout and we have our spec template. And so layouts enable us to start to compose various different units. As I mentioned earlier, the composable units of spec templates. So being able to take various spec templates and have that reusability across different layouts provides the capability of specifying various different versions of the code, as well as being able to really lay out the deployment in a very complex manner. So we get provided a name, provided a generic version. ARM was specified as the technology, and we added the spec template that we had. And we have the spec template that rolls up to the layout, and the layout rolls up to an instance type in this case. So I've utilized the instance type to create our ARM or facilitate our ARM integration. So we see the layout was there. And so what we have here is the instance type, specified a name, specified a code, and the layout is attached. So if we would click add layout, we could add another layout. But in this case, we already have our layout. And so one of the things I want to do is I'll walk through the what we term as the Power UI, or the Power User GUI, and see what it enables us to do, but then also look at the simplified version via the self-service catalog. So I have my Azure ARM demo app. My group is specified, the cloud is specified. In this case, it knows that it needs to talk to an Azure cloud. And so in this case, I only have one cloud for Azure. So I give it a name, select the given environment. In this case, I've got the layout that we specified. There's an ARM plan. And these fields that we see here have been auto-generated based upon the parameters that were detected in the spec template. So I didn't create any of these parameters. I simply provided the ARM code in my spec template, and they had the appropriate parameters specified in ARM, utilizing the parameters construct. And so it was able to automatically detect the fields and then bubble them up from a request standpoint. And so I wanted to highlight that from the power of being able to avoid needing to specify each and every one of those parameters from a power user request standpoint. But as an example, one of the things I do want to do is walk through being able to simplify this process, as opposed to having the requester walk through the process of specifying all of these various different options at request time. So what I want to do is I want to pare it down to maybe one or two specific parameters that need to be specified at provisioning time to simplify the process. And so one of the things that is powerful about the Morpheus platform is the self-service capability in being able to take what we just saw and provide a number of either pre-canned options or values, as well as being able to add in logic to simplify that process. And so what I want to do is we'll take a look at the service catalog item, and then we'll decompose it to see what all is going on. And so I have a service catalog item. We saw that I switched to the service catalog persona. This could be an option from a persona, what we term as personas, as the default and only persona that a user has. So being able to specify that when they come into the Morpheus platform, the only view they should see is the self-service catalog view. In my particular case, I'm an administrator of the platform that has additional access to the various personas. So I can see all three personas in the platform. But let's come to order our Azure ACI. So what we see is a number of options, one being application name, application size, CPU cores, and memory. One of the things we'll look at is the flexibility of the platform to be able to lock some of these components. Right now we see no options found for CPU cores and memory. That was intentional. And one of the things that could also be done is hiding those particular fields, but I wanted to show them for a better understanding of the capability of the platform in terms of being able to dynamically select or toggle certain options. In this case, I want to specify a name. So I'll do tech brief 01. And so right now we see that it's saying no options found for CPU cores and memory. But one of the things I want to do is select a given application size, either small, medium, or large. And so one of the things that we'll notice is that the subsequent fields dynamically loaded. In this case, CPU cores was changed to 1, memory was changed to 0.5, indicating 512 megabytes of memory. But one of the things you'll notice is that if I come to click on it, I only have a single option. So if I change the application size to medium, once again, I'm presented only with single options for each of these. So that's why I mentioned there's the possibility to have hidden these to where all the requester sees is the application size. And then ultimately that maps to a given number of CPU cores as well as a given amount of memory. I left it here and didn't hide it just to be able to easily show what it's actually doing from a logic standpoint. And then finally, we've got large, which then maps to 4 cores and 4 gigabytes of memory. So what I'll do is I'll go to small, and then we can see what's happening, application name. When we looked at the more power user UI from a request standpoint, we saw that there were a number of options that were exposed. And as I mentioned, the thought would be is to simplify that process. So as a requester, all I have to really think about is give it a name and select the size that I want of the actual instance. And then I can go from there. So in this case, we're going to click order. And then I come to my inventory, and what we can see is it's going away now and provisioning the ACI instance utilizing ARM. And then in a few moments, it'll finish up, and then we'll have a new ACI deployment. But as we're waiting on that to finish up, one of the things I do want to do is, as I mentioned, take a look at the self-service catalog view and then decompose it so we can get an understanding of how that's actually facilitated from a back-end perspective. So this might be finishing up just as we're finishing talking. So right here, so right now I'm in the Azure portal under container instance via the ACI, so Azure Container Instances. And we can see that the Tech Brief 01 deployment is pending at the moment that we're deploying into our Azure environment. So right now it is done running, and we can click on it. I can actually, it's what we've provisioned is the generic Hello World application provided by Microsoft. So we've got the link. So let's click on the deployment. Let's see if the deployment is up yet. So right now it is up. So just that quickly, we've utilized Morpheus and an ARM template to deploy our, in this case, Hello World application. Simply that quick. So let's go back into the Morpheus platform, go back to standard view, and we'll decompose what was actually associated with the self-service catalog item. So we come into tools, self-service. We can see in the catalog, we have our Azure ACI. And so one of the things that the Morpheus platform provides is what we term as a configuration wizard to walk through the more powerful UI for the actual request item to generate the code or data that we see here. So in this case, it's a JSON payload. That allows us to easily create self-service catalog items from existing instances or blueprints or operational workflows. And then typically what I will do is I'll go through that process and I'll enter in dummy values for the values that I want to replace. And so oftentimes I'll put something like replace me. And what that enables me to do is then after the JSON payload has been generated, I can then come and replace certain options. So if I scroll down, we'll get more context. So right here we have name. So it's specifying the name of the given deployment. In this case, I created what's known as a custom option in the Morpheus platform, and we'll take a look at that in a minute. That was app name, particular machine readable code or machine friendly name for the particular input was app name. In this case, utilizing camel case. And so this allows us to parameterize the particular values that are specified during the deployment. And in this case, it maps to what we term as option types. So option types are ways to inject user input into the actual deployment process. And in this case, a simplified fashion. And so for us, for this case, we have 4 option types that we've presented. So the application name, which is what we saw during the request process, the application size, we also saw that during the request process. And then finally, the CPU cores, as well as the memory amount. And so we see that we've parameterized the name. If we scroll down, We've used that as well for the host name and the container name. Completely flexible how the values are set, and being able to utilize logic for the process, but in this case, utilizing a simple text field and specifying the name. We see here our image name. The image name could have been parameterized as well. Could have been utilized via a drop-down list, provide a number of options for selecting predefined container images, as well as could have also been a free-form text field. I want to highlight the CPU cores that we have. We can see those, memory amount. And then one of the things that we don't see in our JSON payload is our fourth option type, which is app size. In this particular case, we're utilizing app size as a user viewable selection option that actually defines our CPU and our memory. So that's why we don't see them. And so we'll take a look at how that logic is facilitated on the back end. So from a request standpoint, what's really being entered in is the application name as well as the application size, and the CPU cores and memory are being defined by our application size. As in the example we specified, that a small, medium, and large was utilized as the application sizes. So if we come to provisioning and library, we can take a look at option types in the Morpheus platform, and we can come to our application size option type. In this case, we're utilizing what are known as option list. So option types can tie to option list. Option lists are a way to facilitate the generation or creation of a data set, which is then utilized to present the options that we see in the option list option type. So it's a little bit to understand, but we'll walk through it. So in this case, I've got the option type, which enables me to specify certain fields. So in this case, for the type of option type that we want, we're utilizing select list. So the select list maps to the option list. We've got a number of different options, such as checkbox, hidden, number, password, radio list, text field that we saw, as well as type ahead. But what we want to map this to is a drop-down list of options that we're presented with. So that's why we're selecting select list. In this case, we've got an option list that it's mapped to on the back end. One of the things to note is field name, which is actually what we're utilizing as the machine-friendly name for the particular field, and is what we saw in the custom options dot field name. In the example, it was app name, app size, and then the amounts of CPU and memory. So we looked at the application size. Let's take a look at the option list that maps to that. This particular example, we're utilizing a static, or in Morpheus nomenclature, a manual option list. So that allows us to manually specify the data set. Morpheus platform also supports a number of other types for option list, including LDAP, interfacing with the Morpheus API to pull data out of the Morpheus platform, as well as REST API calls for interfacing with external systems. In this case, I have a static list that I want to specify. Our options are small, medium, and large. And so from a visibility standpoint, the name in the array for the value maps to what the user is presented with. And then the value is what is actually utilized from a machine-friendly standpoint. So that's what actually gets passed into the system for use there. And so we've got our small, medium, and large. But now what we need to do is we need to map that to our actual values for the CPU as well as the memory. And so if we come to, we'll go back to option list. It'll make it a little bit easier to understand what's happening here. So we have our small, medium, and large option or data in our option list. And so we've got another JSON payload that has small, medium, and large. And simply what we're doing is utilizing these as keys to another subsequent set of values. In this case, we've got the small, medium, and large, and each of those sizes has a number of selectable values for the size. And so instead of having a single value in the small, medium, and large, we could have specified you have a number of options that could also be selected for CPU and memory. But in this case, we wanted a one-to-one mapping of size to CPU and memory configuration that allows us to then hide the CPU and memory selections. So we can see that small mapped to the single CPU core, medium mapped to the single, to the 2 CPU core, and large mapped to 4 CPU cores. And so what we've done is utilize the small, so the value that we're getting back from application size, and then utilizing name for name and value to then specify. So in this particular case, since we wouldn't be exposing the actual name to the end user, really what we're most concerned about is the value that is being selected. So what we also have is what's known as translation logic. So we need to get from the larger JSON payload to an array of specific values that are then presented to that particular option type. So what we're doing is we're taking the data. And so in this particular case, data is what would be a global variable in this particular case. That is the data that is being that is presented in the data set here. And then we also have input. In this particular case, we're utilizing input, and we see something that's once again very familiar. So the field name that we had for app size or application size is app size in camel case. And so we're utilizing the input of the application size. So when the requester specifies the application size, then we're utilizing that to specify which particular array of values that we want to then iterate over. So if the user specifies small as the application size, we're then pulling this array of values, which is why we saw 1 for CPU cores available for the small size. Similarly, for medium, we saw the 2 become available. So that's the data that we want to iterate on. The thing then becomes, we then have to extract this value and present it in an array, a simplified array of values that would be presented to the option type. So what we see here is that we're taking the given value, that includes the name and value, so in that case, and then we're doing some additional logic. We have a number of print statements just for troubleshooting purposes. And so what we want to do is we want to specify if the input data is null or is not null in this case, then we want to actually do the iteration. Otherwise, that's why we saw there were no options found at the moment. We could also perform some additional logic if we were going to actually expose or show those items, and then being able to iterate or change the value that's presented to the end user. In this case, we're going to hide those options anyways, so we don't need to present that value. And so we're going to iterate over the input data and take the name and the value and then stuff it in our results global variable. So that way it's presented to the end user. So let's take a look at the option type for the CPU cores to round out the example. So one of the things we see is that in the Morpheus platform, there's the dependent field for the option type. So in this case, this field is dependent upon our app size field name, because that's what we want to trigger the logic on. So we specify that, once again, another select list, provided a label for it. And then the option list that we map to is the CPU core list that we saw in our example. And so that's what rounds out the example of being able to specify the given logic for our ARM template example. So being able to come in and provide the name, specifying the application size, and then having it be able to toggle what the values are for our CPU and memory size. And that eventually maps back to our ARM template code to be able to provision the workload that we want. So in this case, if we come to the tech brief, we can come to containers, and we can come to properties, and we can see the CPU cores and the memory map to what was specified in the given request. All right, so as we wrap up this tech brief, a number of things I want to highlight. There is a Morpheus Community Edition that provides a a great way to get hands-on experience with the Morpheus platform. Just go to the Morpheus Hub to be able to download the Morpheus Community Edition by providing some basic information, and then getting the access to the downloads of the platform, as well as being able to get a license key for community use purposes, as well as being able to really just get your hands dirty and see how you can leverage the platform to provision workloads in Azure utilizing ARM templates. And then one other thing to mention is scheduling a demo with one of our SEs by going to morpheusdata.com/demo if you want to get a deeper look into the Morpheus platform and see how it works really in and out, and see how it can help your organization. Thank you for joining this Morpheus Tech Brief.